So before we get started, before we finish up the note sheets today, we're going to look at 74123, I believe.
Testing 1, 2, 3.
Now, looking at this one here, 74123. With any of these here, with addition, subtraction, multiplication, division, and solving, the first thing we really need to do is factor. If any of the denominators factor, we need to factor them. And so looking at this here, x squared plus 5x minus 24 is factorable. And since the third term is negative, our signs are opposite. Factors of x squared are x and x.
Hello? We can hear you. I'm flaring out of the ceiling.
There we go. So,
Yeah.
Testing 1, 2.
Testing. Yeah. Testing. We can hear you.
okay. Exactly. So, question on how we factored x squared plus 5x minus 24. And let's put that away for now. So, we factor that down to x plus 8 and x minus 3. Now, to be able to add or subtract, the denominators have to be the same. Now, since they both have an x minus 3, that's fine. But the right side, x minus 3, is missing x plus 8. So we're going to multiply the top and bottom of this fraction by x plus 8 over x plus 8. Now, the reason we don't multiply the whole thing by it is because it's not an equation. With an equation, we can multiply the entire thing by that set amount, and we're fine. Here, we can only multiply top and bottom. Now, the denominator is just going to be x plus 8 times x minus 3. We're not going to distribute because we're not having to combine like terms. Now, we're also going to multiply it with the numerator.
Testing 1, 2.
Testing 2, 3.
You can hear this coming out of your speaker, not down the hall. Text me and let me know.
Now, before we combine, or actually add these, we'll need to distribute the 3. Because with our addition subtraction with these here, we're actually going to combine the numerators. We're going to combine those like terms, so we can't leave it as 3 times x plus 8. So we'll do 3 times x, which is 3x, and 3 times 8, which is 24. Now that we have the numerator simplified and the denominators the same, we're going to be adding both of the numerators. And the reason we say that we're adding is because of the sign in the middle. Now we could put parentheses around the 12 and the 3x plus 24, but the main reason we do that is just in case we're subtracting, a sign change. But with addition, the 3x is going to stay positive. The 24 is going to stay positive. Their signs will not change. If it had been 3x minus 24 and we're adding it to our 12, it'd still be 3x minus 24. The signs won't change. Still have 3x, but our like terms, 12 and 24, will add together to give us 36. giving us 3x plus 36 over x plus 8 times x minus 3. If there is a greatest common factor, we do want to factor it out, getting us to this point here. Now, even though factoring out the 3 does not give us something in common on top and bottom, we still need to do that just to make sure that nothing simplifies. And this is as far as we would take this. Even though nothing simplifies, there's not a reason to multiply the 3 back through the numerator, and there's not a reason for us to multiply the x plus 8 and x minus 3. We would leave it in this form. We're not going to multiply anything back out. Questions on this here? Any other questions on the homework before we finish up today's lesson? Okay. This is the next one we're looking at, and it's going to be a little bit different, not a whole lot. But the first thing we can find is our restrictions. Now, for these here again, just like yesterday, the restrictions won't come into play too much, but they will tomorrow. Now, when we look for restrictions, we're looking for values, or kind of the variables in the denominator. And there's two places. We have one x with our 3 over x, and our other one is our x minus 5. Because if either one of these becomes 0, we're dividing by 0, and that's one of our restrictions. It does not work. Now, the 1 doesn't have a denominator with a variable. It's just 1. So we don't have to worry about it. And one of these is already done for us. X equals 0. X cannot be 0. Because if x is 0, we have a denominator of 0. It does not work. The other one's x minus 5. We can add 5 to both sides, telling us x is equal to 5. So if x is 0 or 5, we have a restriction. It gives us a value of x that would make the denominator be 0. Those don't work. So if we did solve this and got x equals 5 as one of our solutions, we can just cross it out. It does not work. Questions on this here? Now we're going to do our first step in solving, that least common denominator. What we need to multiply the entire equation by to get rid of the fractions. Well, looking at these denominators, what do we know we'll need to multiply by? What's one of our terms? Well, someone take a guess. What do you think? What's one thing we need to multiply this entire equation by? Because we need these denominators to go away, yes? So the 3 over x, what would I need to multiply it by to get the x in the bottom to go away? X. Because if I multiply everything by this x, our 1 has no denominator, so nothing's going to simplify there. X, and well, x minus 5 are two different expressions, yes? So would they simplify? Now, our 3 over x, will that x simplify? Yes. So this x and this x are gone, yes? Or all of the fractions simplified out. So what are we missing? X minus 5. Because if I multiply this middle term by the x minus 5, it and x minus 5 will cancel out. But we can't just multiply one part of it by x minus 5. We've got to multiply the whole thing. And really what we're multiplying by is what we call a scalar. We're scaling it up by a factor of x and x minus 5. This is the same as if we multiplied by -1 or multiplied by 2. But with this, the middle term, we have -8. that the x minus 5 and x minus 5 canceled because we multiplied it with the numerator. Got x minus 5 over x minus 5, which reduced to 1. So it simplified out. But we still have the x. And our 8 times x is 8x. 3. Well, the x and x simplified out because we had 3x over x, which reduced to 3. But we're also multiplying the 3 by x minus 5. Now we still have the 1. Well, 1 times x is x. And we also have our x minus 5. Questions on how that worked out? So some of it, we can look at the least common denominator and get that expression x times x minus 5. Or we can take it one term at a time. So we took the x, multiplied everything by it, and saw what simplified out. And then looked to see, did everything else reduce? If it did, and we didn't have any fractions, we found it. We found the least common denominator. Well, just x didn't simplify everything out. We still had x minus 5. So then I multiplied everything by x minus 5 and then checked again. And we can do that one expression at a time until everything simplifies. We don't have any more fractions. Now at this point here, we do need to distribute first the x. X times x is x squared. X times negative 5 is negative 5x. Minus 8x is equal to 3 times x is 3x. And 3 times negative 5 is negative 15. Now this one here is a little bit different than any of the ones we did yesterday, yes? Because this one has an x squared term. The rest of the ones we did yesterday only had x to the first. We didn't have an x to a power. So, since it is considered a quadratic, a higher degree polynomial function, we'll need to get it equal to 0. For that, it might be helpful to combine like terms. Negative 5x minus 8x is negative 13x. So what do we need to do first to get this equal to 0? Two things we can move. What do y'all say? What do we want to move first? Because I wouldn't move the 13x, so we can subtract 3x. And the reason I say that is since x squared, I try to keep the variable with the biggest exponent positive if at all possible. If not, that's fine, we could fix it later, but here we can subtract 3x, then we can subtract 15, which gives us x squared minus 16x minus 15. Or, sorry, it shouldn't be minus, it should be plus. I dropped the negative because 3x minus 15, so it should have been negative 15. This means we should have added it, not subtracted it. Because I was about to say, because if it was x squared minus 16x minus 15, it wouldn't actually factor. Questions on this here? Now we need to solve this here, x squared minus 16x plus 15, yes? We have many different ways to solve this. Because we have the quadratic formula. I'll write it here, you don't have to. Our negative b plus or minus square root of b squared minus 4ac all over 2a. We have factoring. We could factor it down, and any time we have two or more things multiplied together to equal 0, one of them must be 0. We have completing the square, and we also have graphing. Any of these work. Because we could graph it. We can type in the graphing calculator x squared minus 16x plus 15. Because when we graph it, we're trying to see what values of x make the y value be 0. Well, it does give us one of them. Here, second graph. And one of our values is 1. So we can come back over here and say x is equal to 1. Now we need to find the other x value. So we have this here graph. Now what the other is going to either be to the left or to the right of this point. And it's actually going to be to the right of it. Because I can look at the table, and we can go down here to 15. So the other value is 15. Questions on this here? There's different ways we could have gotten to that other value. Because if this is factorable, and the fact that we found one rational or one integer solution tells us that it is, well, what are the factors of 15? 1 and 15, 3 and 5, yes? So if 1 was one of the solutions, most likely 15 is going to be the other factors of 15. So we can look at positive or negative 15 and go from there. Questions on this here? Are either one of those one of the restrictions? No. Questions on anything we've done so far? Any questions on this here? You feel good with this so far? I think it's going to be better to do another one like the one we just did. Because that one there, the previous one, is a little bit simpler. It's just 2x and our other number. Okay. Restrictions. So we have two places where the denominator could be 0. One of the places is x, the other is x minus 4. Because if either one of these is 0, the denominator will be 0. We can't have that. X equals 0, well, I've already got x by itself. We're found what value of x would make that be 0, and that's just 0. X minus 4, well, to figure out what value of x would make it be 0, add 4 to both sides, telling x is equal to 4. So if x was 4, the denominator would be 0. It doesn't work. So our two restrictions are 0 and 4. Okay. So that's good to know. Now we can actually start solving. So when we look at this here, 1 minus 2 over x minus 4 is equal to 4 over x. We need to multiply this by our least common denominator. We need to multiply it by an expression to get these denominators to simplify out. What's one thing, or one part of the expression we would multiply this entire equation by? X minus 4. Because we would multiply everything by x minus 4. Because when we do this here, the middle term's x minus 4, and this x minus 4 will cancel. Because when we multiply it, we would have 2 over x, 2 times x minus 4, all over x minus 4. X minus 4 and x minus 4 would cancel. Our 1 doesn't have a denominator, so we will still have the x minus 4. And unfortunately, our x minus 4 and this x are not the same, so they don't cancel. So what else do we need? X. Because here, the x and x will cancel. Because we'd have 4x over x. Our x over x reduces to 1. So that last denominator is gone. Are there any other denominators left? No. So the x and x minus 4 simplified every denominator, leaving us with 1 times x minus 4. Well, 1 times x is just x. So we have x times x minus 4 minus 2 times x, and that's it, equals 4 times x minus 4. Questions on how we got to this part here? So we feel good with at least getting to here. Yes? Now it's just simplifying. So the first thing we can do is distribute the x. X times x is x squared. X times -4 is -4x. Minus 2x is equal to, again, we'll distribute the 4. 4 times x is 4x. 4 times -4 is -16. What can we do next? Combine like terms. X squared doesn't have any like terms, but our -4x minus 2x is -6x. Well, we have an x squared term, yes? So we need to get the equation equal to 0. We can add 16 to both sides, yes. If we add 16 to both sides, we get x squared minus 6x plus 16 is equal to 4x. What can we do next? Well, we still need to move the 4x, yes? So we could subtract 4x from both sides, telling us x squared minus 10x plus 16 is equal to 0. Questions on how we got to this point? So we all good getting to here? Now from here we can graph it, we can factor it, quadratic formula, any of those methods. I have a feeling we'd prefer graphing, yes? If it is graphable, so here, what equals x squared minus 10x plus 16. We see that it does cross the x-axis in 2 places. And if we look at the table, those 2 places are 2 and 8. Because we're looking for what values of x make the y value 0. Because when x is 2, the y value is 0. When x is 8, the y value is 0. And neither one of these is one of our restrictions. So both 2 and 8 work. Questions on this here? Because we could have factored this if we wanted. We would get to the same place. Because if we factor this here, 2 sets of parentheses equals 0. Since our third term is positive, the signs are the same and match the sign in the middle term. Our factors of x squared would be x and x. Well, the factors of 16 that we want would be 2 and 8. Well, you might be saying, well, our answers were positive 2 and positive 8. We have negative minus 2, minus 8. That's fine. Because at this point here, we're saying that x minus 2 times x minus 8 is equal to 0. So one of these must be 0. Well, then solve for x. We would add 2, telling us x is indeed 2, like we found from graphing here. We'd add 8. So x is equal to 2 and 8. We find the same thing. Questions on this here? Do y'all want to look at one more of these or start the assignment? One more? You want to look at this one or the one we skipped? Yes, okay. Let's see here. Did we skip? We did this one, yes? Okay, so we can look at this one, or the last one. Any one of those three that y'all want to look at? This one here? Okay. Restrictions. Well, restrictions are a little bit easier with this one here because x only shows up in two spots, but it's just x by itself, yes? So the restrictions for this here is x cannot be 0. Because if we just have the variable x, there's no addition and subtraction with it, it's just telling us it can't be 0. Okay, so we have 3 over x plus 5 over 2 equals negative 12 over x. Why do we need to multiply everything by to get the denominators to go away? 2 and x, 2x. Because we need the 2 for our middle rational expression, and we need the x for the other 2. Because when we multiply this here, the first one, the x and x, would cancel, leaving us with 3 times 2, which is 6, plus our middle term, all the 2 and 2 would cancel, leaving us with 5x. That's instead going to be negative, but our x and x would cancel, leaving us with 12 times 2, which is now if we wanted to, we could have rewrote this as 3 times 2x over x plus 5 times 2x over 2 is equal to negative 12 times 2x over x, because really that's what we're doing. We're multiplying each numerator by this amount. And here, again, the x over x would cancel. 2 over 2 would cancel. And lastly, x over x would cancel. We can, yes, kind of like as we did the last one. The big difference between this here and the last one is our x. Because in the last one, the variable with the biggest exponent was x squared, yes? Since it's a quadratic, we need it on the same side equal to 0. Because there, we can't just have x squared and solve nicely. Here, x is to the first, yes? So we could do that. And we can show you that here. I'll show you that here. Because we can add 24 to both sides. Which tells us that 5x plus 30 is equal to 0, yes? So we're trying to find out what value of x would make 5x plus 30 be 0. And I can come over here and I can actually graph this. We can say 5x plus 30, not 0, 3, 0, graph. And again, we're trying to see what value of x makes the function be 0. And we see it does cross over here in the negatives. And it is negative 6. So we would say x is equal to negative 6. And that's it. So it still works for this here. What we could also have done is got the 5x and the 30 on opposite sides of each other, which would be 5x equals negative 30. I'm going to divide both sides by 5, telling us x is negative 6. Because since our only variable is just x, we don't have x squared, x cubed, x to a power, we can get x by itself. Numbers on the other side, and we get our answer also. On the last two, because we had an x squared, a quadratic term, we need to get it equal to 0. We can graph it, factor it, do those processes for quadratic formula. Does that kind of make sense, the difference between the two? Yeah, but we could get this equal to 0, graph it, and that works too. Both of those will work. Unfortunately, we can't use the quadratic formula on this because our a term is 0. Quadratic formula is over 2a, so it falls apart for it. Any other questions on this here? that is it for this here. Now, we will be doing more solving tomorrow. And those will actually have restrictions. We'll have a little more to them. We'll see more of these.